Hey everybody, this is Mr. Ainsworth, and we're going to get into a big review here on solving quadratics. It's important that you guys have a red pen out, highlighters, and so you can annotate all the key points and put the steps in here. And it's also important to have your notes out side by side with this. So take your notes out, have your red pen, pencil, eraser, get ready to go so that I can help you out and teach you how to learn how to use your notes to help you review for a major test here on Friday. All right, so get right out to it here. Let's open your notes to Q2 on solving by factoring. Now let's look at this. Solve each equation by factoring. That's our first lesson. That's the first thing we learn as an Algebra 1 student when we solve quadratic functions, which are second-degree equations here. So let's get right into it here. Take detailed notes. Remember that you should also pause and play. Pause and play. If you're watching this video here, if you need to slow me down, pause it, take some notes, rewind it, do whatever it takes to understand the material well and go at your own pace. So pausing and playing through the video and learning how to use the technology here is really, really important. Okay, so what we're going to do here on our first lesson here, solving by factoring, is we're going to set this equal to 0. All right, that's important because we want to create a zero product. And right now it's not equal to 0. So, okay, so let's add the opposite here. And let's add a negative 2m to both sides, or subtract a 2m. And we get m squared minus 2m equals 0. And step 2 would be to make this a zero product by factoring. You always want to, in this case, you want to factor that, all right? And there's a GCF of m here. And the reason why is because we have a zero product rule. Let me state it. The zero product rule, and write this down too, right? Above here at the very top, what states this: if m times n equals 0, all right, then m equals 0 or n equals 0. One of these factors has to be 0. This is called what's known as the zero product rule, and it's the most fundamental rule that we use in algebra when it comes to factoring and solving quadratics. Now this is a difference of two terms. This is not a zero product. A product means you have to multiply two things. And that's what factoring does for us. So let's factor out the GCF here. M times m is m squared. M times 2 is 2m. All right, you just got to be thinking, m times m is m squared. M times 2 is 2m here. Bring down the minus sign. Now this is called a zero product because we have m times m minus 2 equals 0. So the next step would be to set each factor equal to 0. So either m has to be 0 or m minus 2 has to be 0. All right, m equals 0 is one solution. If we add 2, or just think about it, since 2 minus 2 is 0, m equals 2 has to be equal to solution 2. Why? Because 2 minus 2 equals 0. If I put a 2 in, you get 0. Why? Because 2 minus 2 is 0, and 0 times anything is 0. That's what the zero product rule is all about. All right, the most fundamental factoring rule in Algebra 1. We even use it in calculus too. Now this one here can be solved many different ways, but in number 2 here, we have, if we subtract 49 and set it equal to 0, we can solve it by factoring. We get x squared minus 49 equals 0. And there's no GCF here, but we can play the game. What two numbers multiply to negative 49 here and add to 0? There's no middle term here, guys. The middle term has to be 0. Well, that's negative 7 times positive 7, right? Well, so let's factor that as a difference of squares. By the way, this is 7 squared. So we can go straight to factoring x minus 7 times x plus 7, because this is what's called a difference of squares right here. If you open up your notes to the difference of squares, we go directly into the factoring right here versus doing it by factoring by grouping. Now, once you have a product equal to 0, what's called a zero product, one of these has to be equal to 0. And so x minus 7 has to be 0, or x plus 7 has to be 0 for a zero product. One of these babies has to be 0, guys. And since 7 minus 7 equals 0, x can be 7 here. And since negative 7 plus 7 equals 0, well, x has to be negative 7 here. All right, not too hard here. Okay, not only that, if you take these answers back up here and substitute them in the original equation, 7 squared is 49, and guess what? Negative 7 is 49. By the way, just so you know, x squared equals 49 can be solved by our other method here by square roots. We could square root both sides, put the plus or minus symbol in there, and get x equals plus or minus 7 the quick way. So this one can be solved by two different methods here, by square roots or by factoring. The next one here, number 3, if you're going to solve this by factoring, you got to set this equal to 0 first. So set equal to 0 first. Well, to do that, you got to add the opposite, right? So the opposite of a minus 8b is a plus or positive 8b. The opposite of a minus 7 is a plus 7. And then you just read it from left to right, or from top down, starting with the highest exponent. B squared plus 8b plus 7 equals 0. Okay, you set this baby equal to 0 and you factor, and you play the factor game. All right, what two numbers multiply to 7, add to 8? Well, we know that 7 is prime, and the only factors of 7 are 1 and 7. So 1 times 7 is 7, and 1 plus 7 is 8. So we're going to split the middle term and do some factor by grouping here. So plus 1b here, using these factors now, we're going to split the middle term into 1b plus 7b. So we have plus 1b plus 7b plus 7 equals 0. We split that middle term, we factor out a b and do some factor by grouping. B times b is b squared, b times 1 is 1b. I factor out a 7 because they both have that as a factor. 7 times b is 7b, and 7 times 1 is 7. And notice that the binomial is in common here, the b plus 1. So let's factor that out. And I'm talking about, let me switch to blue now. That's the common binomial, and then you got to multiply it by what's in the remaining factors. So let's multiply that by, well, put that back, by another b plus 7. Why? Because that's the remaining factors, right? I've only done this for like 3.5 weeks straight every single day, so hopefully by now you guys have got it. I'm hoping. You just got to practice enough to get it down. All right, now one of these has to be 0, right? So b plus 1 has to be 0, or the b plus 7 has to be 0. And since negative 1 plus 1 is 0, b has to be negative 1 here. And since negative 7 plus 7 equals 0, b has to be negative 7 here. So we have two solutions again. Keep in mind that all these quadratics have a maximum possible solutions of 2. Either 2, 1, or 0 solutions. Remember that. The degree of the equation tells you the number of solutions possible. They have 2 possible solutions. Now, number 4, it's just like it's just like here, number 1. It has a GCF here, so we want to factor it out. So let's factor it out here. N times n is n squared, and n times 3 is 3n. Set each equal to 0 and solve. It's the same process every single time. Once you have a 0 product, you set each factor equal to 0 and solve. Let me write that down. So set each factor and solve. All right, and you see me do that here, and you see me do that here. Okay, and now since n equals 0 is already solved for, and just solve the other one. All right, since negative 3 plus 3 is 0, the answer has to be negative 3, right? So you have two answers, 0 and negative 3. Once again, these solutions here, or these quadratics, have 2 solutions. And you just got to get good at factoring and practice like mad. And I'm telling you guys, even if you have to do each one 3 or 4 times in a row before a test, do whatever it takes. Get the practice that you need and go for it. Like this one, it's not set equal to 0, right? So we have to set equal to 0 and do whatever it takes. If you see a 3r, well then subtract 3r. Always add the opposite there. And you get r squared minus 3r, put in descending order, minus the 18 equals 0. And then play the factoring game again. So what two numbers multiply to negative 18 and add to negative 3? You know, pause the video and go for it. All right, well hopefully you selected negative 6 and 3 here, positive 3. 3 times negative 6 is negative 18, and negative 6 plus 3 is negative 3. So if you know how to multiply numbers, well this is not too bad, is it? Now we're going to split the middle term. We've got r squared minus 6r plus 3r. We're going to do some factor by grouping once more, since that's our main technique. Factor out the GCF. 3 is the GCF here. Factor out a common binomial. I see an r minus 6 in common. Let's write that down first. Let's multiply it by the remaining factors, r plus 3, and put that here. And get r plus 3. And now we have what's called a zero product in. So you set each factor equal to 0. So set r minus 6 equal to 0, r plus 3 equal to 0. Solve them both, and you get r equals 6. 6 minus 6 equals 0. Negative 3 plus 3 equals 0, so it's got to be negative 3 over here. And you can see it right now, r equals negative 3. So r equals negative 3 and 6. You can write these down in either order. Usually mathematicians write the smaller number first and then the bigger number. So it's the same thing we did in our lessons, but now we're working on speed and recall and making sure that you get good at it. All right, it's all the same steps in all through the lessons, and they're all done the same way. The question is, can you get to the point where you're really good and you can solve them quickly? All right, and that comes through a lot of practice. Now on this next one here, it's not equal to 0 either, so I'm going to add the opposite again. The opposite of a negative 4n is positive 4n, and that's why you see me doing that. And the opposite of 3, well, excuse me, the opposite of negative 3 is adding 3. So these cancel out to 0. So my right side's 0. My left side is n squared plus 4n plus 3. N squared plus 4n plus 3. Just read it from left to right. Learn how to train yourself right here. Look at this. N squared plus 4n plus 3. Just train yourself how to read it. And then play the factor game again. What two numbers multiply to 3? 1 times 3 is 3. And add to 4. Well, 3 is prime, right? So there's only one choice. 1 times 3 is 3, and 1 plus 3 is 4. This is easy. So you do some factor by grouping. You can pause the video at any time here and work ahead. And that's how you should be using this technology, by the way, is you should pause the video, work through the problem, and don't think you're right. You know, don't assume that you're right. Press play and go through the problem and check yourself. We got n squared plus 1n plus 3n here. 4n is 1n plus 3n, plus 3 equals 0. Factor out an n, factor out a 3. Remember that binomials here are all the same, always the same in the factor by grouping. Here and here, they're always the same. And we get n plus 1 times the remaining factors, n plus 3, and that goes in the second binomial. Now you have what's called a zero product again. So you do what you just did on the problem on the number 5. You set them both equal to 0. Okay, it's the same thing every single time. And what you guys have to do is get used to it, and so you can be as fast as me. All right, and you can be, by the way. I have some students that are this fast. I have plenty of them. The question is, are you going to practice well enough to get this fast? All right, and that's why we're doing this review right now. Is we're going through these problems again, because it takes a lot more than one repetition so that you can get good at it. All right, and the first 6 problems were all done by factoring. That's lesson Q2, or lesson 2 in my unit with you guys. Now the next lesson is called completing the square. Now the completing the square lesson is my, oh shoot, you know what? I don't want to do this lesson first. Well, I can do this as a review. It doesn't matter whether you're going in order. Well, actually, you know what? I'm going to go out of order here because, you know what, my second lesson is on square roots, so I'm going to go out of order. So everybody turn to number 11 if you haven't done so already. And this is Q3, my third lesson, so open your notes to Q3, third lesson. And we are going to solve these equations by square roots. Notice there's no x term here, it's a constant. So all we have to do is isolate the squared term first. Now if you open up your lesson and your notes to Q3, you'll see that. I said isolate your x squared term. Well, let's do that. Let's divide both sides by negative 7. All right, negative 7 divided by negative 7 is 1. Negative 68, 168 divided by 7, then negatives cancel. Let's go off to the side. 168 divided by 7, well, it divides 2 times, remainder 2. 7 into 28 is 4, so it's 28. And then after you isolate this x squared, step 1, step 2, well, that's square root both sides. If you look at your notes, that's what we wrote down. Square root both sides. So square root here and here and put the plus or minus symbol in there. The square root cancels out the square, giving you n, and you get plus or minus root 28, which has to be simplified. All right, so let's write down the word simplify. Now we know that 2 times 14 is 28, and we also know that 4 times 7 is 28. So let's pick 4 and 7 as our factors because, well, because 4 is a perfect square, right? Always write the square first. So root 28 is root 4 times root 7, and that's plus or minus 2 rad 7 or 2 root 7. That gives us two answers, 2 root 7 and negative 2 root 7. See, that plus or minus symbol means positive and negative 2 root 7. There are two solutions to these bad boys. All right, number 12. We got to isolate p squared. Let's divide by negative 1. Real simple, right? So we get p squared equals negative 16 because 16 divided by negative 1 is negative 16. And since this is positive, you know, something squared is always positive, and this is a negative, we know they can't be equal to one another, and because of that, there's no solution. You can try square rooting, but you can't square root a negative. So once you square root the negative 17, you're not going to get a real number. There's no, well, okay, no real solution. Put that in there. All right, there's an imaginary solution, guys, but you're not in Algebra 2 yet, and I'm not going to teach that in this lesson. Okay, so keep that in mind. Let's highlight this. A positive can't be equal to a negative. All right, therefore no real solution. Now we're going to go back to my next lesson here. Instead of going to the quadratic formula, we're going to go back to completing the square and work on that now. Why? Because that follows the square root technique. Now whenever you complete the square, all right, you're going to take b and divide it by 2 and square it, and you're going to add it to both sides. So I'm going to write that down. Add the square to both sides. That was a big step in the completing the square technique. Now b is always the middle coefficient. It's bx. Remember, it's ax squared plus bx plus c equals 0. So a is 1, b is 18, and c is 77. So what you want to do first is you want to isolate your variables and get the constant on the right by adding the opposite. So let's subtract 77 on both sides. And let's leave room to complete the square. So I'm going to go plus blank equals negative 77 plus blank here. We have to add a constant, it's called a square, okay, to both sides so that it becomes factorable. Because the initial equation is not factorable. I don't know about you, but I don't know two numbers that multiply to 77 and add to 18. Factors of 77 are 7 and 11. Ooh, it is factorable. Okay, but you know what though? We're not going to solve it by factoring. So don't do that. Okay, so completing the square technique works even when it's factorable. It solves everything, believe it or not. But typically it's used when it's not factorable. And, well, this one is. But I don't want to solve it by factoring. Okay, so what we're going to do is we're going to take 18, and I'm going to erase all this here. Because I don't want to solve it by factoring. I want to solve it by the completing the square technique. And I'm going to ask myself, you know, hey, what's 18 divided by 2 squared? You got to take b, which is 18, and divide it by 2 and square it. Well, that's 9 squared, or 81, and that's what I want to add to both sides. All right, so I add 18 to both sides. You remember in algebra, whatever you do to one side, you add to the other side. Remember that. Okay, now we play the factor game. All right, what adds to 18 and, multiplies to 18? Excuse me, not 18. Why did I say 18? It's supposed to be 81. Let me change that. That was an obvious mistake. Okay, I said 81, right? Okay, so let me change that. It's supposed to be 81 here. Add 81 to both sides. That's better. I'm dyslexic, guys, so sorry about that. I get things backwards. Okay, I write down 81 and then I say 18. I don't know why I do that, so I got to be careful. So what two numbers multiply to 81 and add to 18? All right, and it's, guess what? It's right here. All right, it's 9 times 9. Now 9 times 9 is 81, and 9 plus 9 is 18. It's always b divided by 2. That's always the number there. So we're going to use that in our factor by grouping. So we're going to split the middle term and split the 18x into 9x and 9x. All right, we always split the middle term by factor by grouping. You guys already know that. 81 minus 77, well, that's 4. Okay. Factor out a common factor. Okay, the common factor here is x plus 9. We're going to factor that out. We've got x plus 9 times the remaining factors, x plus 9. That goes there. And that's equal to 4. We're going to rewrite it as 1 binomial squared. And then it looks just like my previous problems. We're going to square root both sides. Okay, so let's go for it. Square root, put the plus or minus symbols in. The square root cancels out the square, giving you x plus 9 equals plus or minus 2, and we're almost done. Subtract 9, and you get x equals negative 9 plus or minus 2. Negative 9 plus or minus 2. That gives us two answers, negative 9 plus 2, or negative 7, and it also gives me negative 9 minus 2, which is negative 11. So if you try to factor this and solve it by factoring, you're going to get the same two answers. Because it doesn't matter the technique you use to solve it, it matters whether you do it right or not. Okay? So try to solve it by factoring. I challenge you and you get the same solutions. All right? Try to solve by factoring on your own. All right, by factoring and get the same solutions. Okay, now let's do it one more time here, and in fact we're going to do it 3 more times to get really good. Why? Because that's what it takes. I keep on saying this, it takes a lot of practice to get good, and if you guys don't study well and do your homework well and check all your work and have quality work, don't plan on getting an A on the test. Okay, it takes a lot of practice. All right, so after this video here, print off another one and practice whatever you're not good at and get good. Okay, now just like the number 7 here, I need to get the constant on the right hand side. I'm going to add the opposite, so I'm going to add a 48, and I get x squared plus 6x plus blank equals 48 and 7, that's a 55. Plus something here. Whatever I add to one side, I'll add to the other side. Remember, whenever you complete the square, you got to add to both sides. So b here is 6. So 6 divided by 2 squared is 3 squared, or 9. So I got to add 9 to both sides, right? Well, let me see. The right side 65. No, excuse me, 64. Ooh, that's a nice number. Okay. Now we play the factor game. What two numbers multiply to 9 and add to 6? And you know them. It's right here. 3 times 3 is 9, and 3 plus 3 is 6. It's always half a b, like I keep saying in every single example in all my lessons. It's always half a b. Notice right here it happened the same thing. So x plus, or x squared plus, I'm going to split the middle term now, 3x plus 3x, notice how I split the middle term, plus 9 equals 64. 55 and 9 is 64. Factor out a common factor as we always do. Notice that I'm not explaining everything now because we're in review mode, right? You guys should know this already. And if you don't, you should need some serious one-to-one tutoring here because you're behind, all right? And so I would say to you that you should get some major help because what I'm doing now, after 3 weeks of day-to-day work, you should know how to do it. So you factor by grouping, write it as 1 binomial squared, and just like the previous one, you want to square root both sides and put the plus or minus symbol in there. I'm repeating myself over and over again. The only thing that changes are the numbers. So what you guys got to get is the method, the strategy, the step-by-step approach of how to do this. And if it takes doing all these 2 or 3 times a piece, then do it. And then when the light bulb goes on, you'll look back at all your hard work and go, ah, I get it now. And once that happens, well, it's easy. Okay? The square root cancels out the square, giving you x plus 3, plus or minus root 64, which is 8. All right, I need to subtract 3, and I get x equals negative 3 now, plus or minus 8, which means two things. Negative 3 plus 8, which is 5, and negative 3 minus 8, which is negative 11. So once again, I have two answers, 5 and negative 11, in either order. All right, Now that's 2 out of the 3. And remember, this is a video, so if I go too fast, well, pause it, rewind it, and play it again. And it's a video, so learn how to use your technology and listen to it over and over again and practice well enough so that you can do it on your own. That's exactly what I do in college. When I learn lessons from my instructors is if I have videos available, I will listen to them over and over again until I understand it fully and until I can do it on my own. You need to learn to do the same, okay? You guys, we have the internet nowadays, so YouTube and TeacherTube and all the different video channels that are available for you guys, you got to learn how to use them to your advantage. And this is one example too, also on my website. Now this one here, I noticed that 7 and 14 and 56 are all divisible by 7. So before I complete the square, I need to make the lead coefficient 1, because I cannot complete the square when the lead coefficient is 1. So what I'm going to do is I'm going to divide everything by 7, and I mean everything, all 4 terms, left side and right side. 7 divided by 7 is 1, giving you n squared plus 2n minus 8 equals 0. 14 divided by 7 is 2, 56 divided by 7 is 8, and 0 divided by 7 is 0. And now I can complete the square. I'm going to get the constant on the right just like I did the previous 2 problems. Get it over here, adding the opposite. I got n squared plus 2n plus blank equals 8 plus blank, and I got to figure out what to add on both sides. So we play the game again. Here's b. b is 2, and I take b divided by 2 and I square it. So for me, it's 2 divided by 2 squared, which is 1 squared or 1. So I got to add 1 to both sides. And that makes it really nice because guess what? The right side's 9 now, and that's a perfect square. So when I root it, it's going to be easy. Then I play the factor game. What 2 numbers multiply to 1 and add to 2? And that's not hard either. 1 times 1 is 1, and 1 plus 1 is 2. So we want to split the middle term, right? As we always do. So n squared plus 1n plus 1n plus 1 equals 8 plus 1 or 9. I factor out an n out of the first group. I factor out nothing out of the second group. I just write it as 1 times the quantity n plus 1. Just give it a hug, guys, okay? Watch this. All you do is give it a hug and group it. Why? Because this is factor by grouping. All right, so factor out an n plus 1 right here. Multiply it by the remaining factors here, n plus 1, and put it in. Okay, so here we go. We got n plus 1 times itself equals 9. That's n plus 1 squared equals 9. And at this point, look right above it, the 2 right above it. Well, we square rooted, right? Well, you want to do the same thing. So square root again, put this plus or minus symbol in there. And you get n plus 1 is equal to plus or minus 3 because the square root of 9 is 3. And after you subtract 1, we get n equals negative 1 plus or minus 3, which means 2 things. Negative 1 plus 3, which is 2, and it means negative 1 minus 3, which is negative 4. Now what I want you to do is pause the video and give the second one a shot, because here they're all divisible by 5 and you can divide everything through by 5. So make that happen, work ahead of me, and use number 9 to help you out. All right, let's check your work. Let's divide through by 5. Everything. Make sure you check your work as you go. P squared minus 4p minus 12. 60 divided by 5 is 12. All right, is equal to 0. 0 divided by 5 is 0. Now, instead of factoring, which we could do, I'm going to complete the square. So get this constant on the right by adding the opposite. I get p squared minus 4p plus blank equals 12 plus blank. We're going to complete the square. Now b is negative 4, so here we go again. Sorry, let me fix this here. B divided by 2 squared. There we go. Now, what is negative 4 divided by 2 squared? Well, negative 4 divided by 2 is negative 2, and when you square it, you get 4, so we want to add 4 to both sides. And then we play the factor game. All right, what 2 numbers multiply to 4 and add to negative 4? And guess what? It's right here. Negative 2 times negative 2 is 4, and negative 2 plus negative 2 is negative 4. So whenever you take b and divide it by 2, that's the number that you use. Just keep that in mind every single time. So split the middle term, all right, minus 2p plus 4 equals 16. Ooh, how nice is that? Factor out a p, factor out a negative 2. Be careful right here. When you factor out a negative, negative 2 times p is negative 2, and negative 2 times negative 2 is positive 4. So be careful right there. Factor out your common factor of p minus 2. That's in common, so factor it out. Multiply it by the remaining terms, which is p minus 2. Set that equal to 16. Rewrite it using exponents. Now square root both sides. And, like I said it before in the previous problems, I know this is a video and I'm going a little bit fast, but you're checking now. Use the pause and play button, okay, to your advantage. All right, we got p minus 2 equals plus or minus 4. The square root of 16 is 4, not root 4. Add 2, and you get p is equal to 2 plus or minus 4, which means two things. 2 plus 4 is 6, and 2 minus 4 is negative 2. So my two answers are negative 2 and 6. Over here on the previous one, my two results are 2 and negative 4, or negative 4 and 2 written in either order. Now the completing the square technique works on everything. You can go ahead and use that technique and solve every single equation, but typically it's used when it's not factorable. All right, but once people get this technique, man, it's nice. Unless, of course, the middle coefficient, b, is odd or it's a fraction, and then it gets a little bit more tough, but that's where you kick in other techniques like the quadratic formula. Okay, speaking of quadratic formula, let's go to number 13 and let's work on these. Okay, now this is my last lesson. All right, we're going to solve by the quadratic formula. Open your notes to Q5 right here, and let's use the quadratic formula, and let's write it down first. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Keep in mind that you should put parentheses around all your variables because you're going to be substituting them in. Okay, so the very first thing is we set it equal to 0, just like all the other ones, right? And this one's already set equal to 0, so we can just go for it and write down a, b, and c. Now a is 1, 1x squared is x squared, so a is 1, b is 2, c is negative 1. Make sure you write these down first, because if you don't know what these are correctly, well then forget it, you're not going to get the right answer. And then you want to substitute them in. You take the opposite of b, which is 2, plus or minus the square root of b squared, or 2 squared, minus 4 times a, which is 1, times c, which is negative 1, all divided by 2 times a, which is 1. So that first step is called substitution. What do we get? Well, you get a negative 2. You get a negative 2 here, plus or minus 2 squared, or 4. Now right here, look at this. I'm going to add the opposite here. I should have put that in red right here. And I see that a negative 4 times 1 times a negative 1 is a positive number, so I'm going to put a plus sign. Most of you guys add the opposite like that. 4 times 1 is 4, times 1 is 4. All divided by 2 times 1, or 2. Okay, and now what we have to do is simplify. So we get x is equal to negative 2 plus or minus root 8, all divided by 2. You're not done yet. Root 8 can be simplified. You got to split the root. So negative 2 plus or minus root 4 times root 2, all divided by 2. You have to split the root and simplify. Split the root. All right, and simplify. Well, we know root 4 right here. Well, that's just 2, isn't it? So we get negative 2 plus or minus 2 root 2, all divided by 2. And now at this point, probably the easiest way, and this is the way I taught the lesson, is divide all your coefficients by 2. Okay, the negative 2, the 2, and the 2, divide them all by 2. So over here, you're going to get negative 1. 2 divided by 2 is 1. This 2 divided by 2 is 1. Giving you negative 1 plus or minus 1 root 2. Negative 1 plus or minus 1 root 2, which is just root 2, all divided by 1, which doesn't affect anything. I mean, if you do that, that's fine, but typically people write it like this. Why? Because when you divide by 1, it doesn't affect anything. And so you get two answers here. You get negative 1 plus or minus root 2. And that's how the quadratic formula is done, everybody. All right, what you need to do is get good at it. So on this next one, go ahead and pause the video and give it a shot. Okay, so here A is, it's already set equal to 0, so A is 5, B is 3, and C is negative 9. So A is 5, B is 3, C is negative 9. So you just want to substitute them in first. The opposite of B, which is 3, plus or minus the square root of 3 squared, B squared, minus 4 times A times C, negative 9, all divided by 2 times A, which is 5. So your very first step is to set it up. So I see right here negative 3 plus or minus the square root. 3 squared is 9. And then we see we got minus, I see, let me add the opposite right here. I get a negative 4 times 5 is negative 20 times a negative 9. So a negative times a negative is a positive, so I'm going to put a plus sign here. 20 times 9 is 180, so plus 180 here, all divided by 2 times 5, or 10. Okay, simplify now. So negative 3 plus or minus the square root of 189, all divided by 10. It's too bad it's not 289, isn't it? Okay, let me see here. That's divisible by 3. 189 divided by 3 is 63. Divided by 3 is 21. Divided by 3 is 7. Divided by 7 is 1. So I see a square here. So, oops, that's incorrect. Let me change that. 7 times 3 is 21. So you got 21 times 9. So this can be factored. So negative 3 plus or minus root 9 times root 21, all divided by 10. And that's equal to negative 3 plus or minus 3 root 21, because guess what? Root 9 is 3, guys. You know that. All right, all divided by 10. And let me see, 3, 3, and 10, they're not divisible by anything. So we are done at that point, okay? If 3, 3, and 10 had a GCF other than 1, I would continue. But like over here, they're all divisible by 2, but over here, they're not. Okay, so I'm done at this point, okay? All right, 2 more to do. All right, so this one's not set equal to 0, so I got to set equal to 0 first, guys, okay? We can't determine A, B, and C without doing that, so I'm going to add 5 here. All right, many people make the mistake of not doing that, and they get the wrong answer because they didn't set equal to 0 first, so make sure you do that. I also noticed that everything's divisible by 2, so I'm going to make my life easier on myself. I'm going to divide them all by 2 and simplify my equation. This doesn't change the answers, it just simplifies it for me, and it makes things easier to deal with. Okay, now on my coefficient here, I see A is 1, right here is B, and then right here is C. So A is 1. I'm not talking about my solution here, I'm talking about my coefficient. I don't like it when the programs, make A as a variable because, well, I use A and B and C as variables, so typically I wouldn't do that. But anyways, let's just go with the flow. B is negative 2, that's equals, and C is negative 5. Okay, all right, so instead of X, well, we have A, right? Because A is our variable. So, whoops. Oh, goodness. Okay, so negative B. So I have the opposite of negative 2. B is negative 2, right? Plus or minus the square root of B squared, so negative 2 squared, minus 4 times A times C, all divided by 2 times A, which is 1. Okay, so now let's go for it. I see a double negative here. I see a 4 here. Negative 2 squared is 4. I like to do this. I cancel the negatives there. 4 times 1 is 4, times 5 is 20, so got to add the 20 there. I'll divide it by 2 because 2 times 1 is 2. So at this point, I just go for it, man. I got 2 plus or minus root. Whoa, getting a little crazy right there. The square root of 24 divided by 2. I got to split the root. So 2 plus or minus, let me see, 24 is 4 times 6. So root 4 times root 6, all divided by 2. I get 2 plus or minus 2 rad 6, all divided by 2. Look right here. This is the same. Root 4 is 2, so you got to simplify. Okay, divide them all by 2. And I get a is equal to 1 plus or minus 1 rad 6, so root 6 all divided by 1. But again, when you divide them by 1, it doesn't affect anything, so you just leave it out. 1 plus or minus root 6, and you're all set. That's it, my friends. Okay, now pause the video and try number 16. All right, so let's add 3, and you get 4v squared plus 4v. Oh, excuse me, that's wrong. I got to add a 2. Scratch that. Okay, I'm human. It's getting late. Add 2. Okay, we got to set the right side equal to 0. Boom, right there. So 4v squared plus 4v. Negative 3 plus 2 is a negative 1 equals 0. A is 4, B is 4, C is negative 1. So let's write them down. A is 4, B is 4, C is negative 1. Always write down your values so you get organized, okay? Negative B is negative 4 plus or minus the square root of B squared. So 4 squared minus 4 times A times C, all divided by 2 times A, which is 4. That's substituting. Simplify it a little bit. We got negative 4 plus or minus the square root of 16 now. 4 squared is 16 minus, let me cancel out the negatives here, and here. So plus 16 here times 1 is 16 divided by 8. 2 times 4 is usually 8. All right. Okay, now 16 and 16 is 32. So negative 4 plus or minus the square root of 32, all divided by 8. And now you got to split the root. We know that 8 times 4 is 32. So this is negative 4 plus or minus root 4 times root, 16 times 2 is 32. So instead of using 4 and 8, I am going to use 16 and 2. So let's change that. So root 16 times root 2, all divided by 8. Now the root 16 right here, that's just 4. So you have negative 4 plus or minus 4 rad 2, all divided by 8. And the only thing left to do now is to understand that 4, 4, and 8 are divisible by 4. So divide them all by 4. Excuse me, that was a mistake. So negative 4 divided by 4 is negative 1. 4 divided by 4 is 1, and 8 divided by 4 is 2. So my answer is negative 1 plus or minus 1 rad 2, which is rad 2, all divided by 2. Okay, and there we go. And that's number 16. All right, what else do we have to do here? All right, oh, these are easy. Okay, so we just have to simplify some roots. Okay, now then we know that the square root of a times b equals the square root of a times the square root of b. So we got to split the root into its factors. I've already said that many times. Split the root. Everybody say split the root. Okay, now we know that, and I just did this, that 32 divided by 2 is 16 divided by 2 is 8 divided by 2 is 4 divided by 2 is 2 divided by 2 is 1. I see a square here and a square here and a bigger square here. So my factors are 16 and 2. So square root them both. All right, and you get 4 rad 2. Now on this one here, we know that 9 times 7 is 63, so this one's even easier. All right, the square root of 9 is 3, so we get 3 root 7 here. On the 128, we get 128 divided by 2, 64 divided by 2 is 32, sorry. I'm thinking of something else. 32 divided by 2, 16 divided by 2, 8 divided by 2, 4 divided by 2 is 2, divided by 2 is 1. So I see a square here, here, and here. I see a square here and here, and we should know that. Okay, 64 times 2 is 128. We should have stopped actually right here. 2 times 64 is 128, so we should have stopped. So we have the square root of 64 times root 2, which is 8 root 2. This one here, pretty simple. Pause the video and try it. Okay, and we got the square root of 4 times root 7, and that's 2 root 7. Done with that one. Okay, next one. Now on these right here, we got to isolate the binomial. So we're going to add the opposite first. We're going to add the 4 first. We're going to isolate that binomial. Okay, so we got x plus 1, quantity squared equals 4. We're going to square root both sides here and here. We're going to put the plus or minus symbol in. The square root cancels out the square, giving you x plus 1 equals plus or minus root 4. All right, what is that? Well, we know that the square root of 4 is 2, so it's plus or minus 2. Subtract the 1, and we get x equals negative 1 plus or minus 2, and that means two things. Negative 1 plus the 2, which is 1, and also means negative 1 minus the 2, which is negative 3. So we get two answers here, 1 and negative 3. On the next one here, it's pretty much the same. We've got to add the opposite here first and then divide by 3. So let's add the opposite first, as we always do in all of these equations here. And we get 3 times our binomial squared equals 27. I'm going to divide both sides by 3, not 9, sorry. We're going to divide by 3. I was thinking of the answer over here. And I get x minus 5 quantity squared is equal to 9. At this point, we square root both sides and put the plus or minus symbol in here. And the square root cancels out the square, giving you x minus 5 equals plus or minus 3. And after we add 5, we get x is equal to 5 plus or minus 3. Since 5 plus 3 is 8, that's one solution. 5 minus 3 is 2, and that's our second solution. And we're done at this point, x equals 2 and 8. Now remember, this is a video. And I know I went fast, okay, obviously faster than you. So use the technology correctly and use pause and play and rewind and go back and through the problem and then print off another copy of this on the student copy and practice like mad, you know, and until you can do it like I do. I have students that are capable of doing this as fast as me because they're good already and they have that kind of practice. You need to do the same thing. All right? This is Mr. Ainsworth. Get ready for your test here. Work hard, make yourself proud, and I'll see you in my next lesson.